Hi, and welcome to this tutorial on how to create a custom connector for Weld. We are going to look at how to step-by-step create a custom connector for the Typeform API. The first step is setting up the development environment. After that, we will implement the endpoint to provide schema information, then the endpoint for the data flow. Then we are going to look at state handling, authentication, hosting in Google Cloud, and finally setting up the connection in Weld. Let's get started. Let's start by setting up our development environment. We are going to develop this custom connector in Python, and as we are going to host it as a Google Cloud Run function, we are going to use the Functions Framework Python package. First, we will create our virtual environment for Python. Then we are going to activate this virtual environment. And finally, we are going to install the required packages, which are requests and functions framework. After installing these packages, we can build the skeleton of the Cloud Function Handler. We'll import the functions framework and Flask packages and create a function that is decorated with the HTTP handler decorator. This function will accept a parameter which is going to be a Flask request. At first, we are going to return Hello World in the response. Now that we have this skeleton, we can start the Functions Framework debug server, and it will be running on port 8080. We can send a request to this local address. We are getting Hello World as a response, so everything is working correctly. Now let's take a look at the Weld documentation for custom connectors. We will need to add two endpoints, the schema and the root endpoint. In the schema endpoint, we are going to provide information about the tables, primary keys, and fields. Fields are optional because they are auto-inferred by Weld, but you can give extra information in order to make the schema more accurate by defining specific types for certain fields. In the root endpoint, we will handle the data flow. We will need to return this specific data format with the insert, state, and has more fields. In the request body, Weld will send the name of the requested object and the previous state. Now we can also explore the Typeform documentation. We will need to authorize our request using an authorization header, and our base URL is going to be api.typeform.com. In this tutorial, we'll implement the endpoint to retrieve forms. This endpoint uses pagination through query parameters, which we will need to handle. And here we can see our response data structure, the page count, and total items fields that will help handling the pagination. Let's implement the schema endpoint first. We will define a new function called getSchema, where we will return a static object for schemas. The schema will contain the form table, for which the primary key is going to be ID. Then we can define the fields where we will add this ID field with a string type. In Functions Framework, the handler will receive a request object which will have a path property. We will need to return the correct response depending on which path was requested. When we hit the /schema endpoint with a GET request, we can return the result of the getSchema function. Let's test our endpoint. You can see that we are correctly receiving our JSON structure for the schema. The next step is implementing the data endpoint. We will create a basic call API function, which will handle our API calls towards Typeform. We can build the URL from the base URL and our desired endpoint. The base URL is going to be the one seen in the Typeform documentation. To this, we will also add the endpoint, which will depend on the object type we are fetching. We will also create a placeholder for parameters. Then we will need to add the headers for authorization. Our authorization token is contained in the environment, so we will need to import the OS package. From this package, we can use the os.environ.get function to retrieve the value from our environment variables. In this .env file, we have the Typeform API key variable, which we are using in the code. Now we can import the requests package and make a GET request towards our URL with our parameters and headers included. We'll check if the response was successful by seeing if the response code is 200. If it wasn't successful, we will raise an error for the status. Otherwise, we will return the JSON body of the response. In our functions framework handler, we would like to see a POST request made towards the root endpoint. In this case, we will acquire the request data from the request body. Then we will create a getData function which will handle our data flow. In the request data, we will see the name of the table that was requested. Based on this, we can define which endpoint to use when calling the Typeform API, using a match case statement to match the table name to an endpoint. Once we have our endpoint, we are going to call the API using our previously defined call API function. After this, we can return the data in the structure that we saw in the Weld documentation. For now, we will hard-code values for hasmore and the state. We will take a look at handling those later. Now let's test our implementation by creating a POST request in Postman towards our development server. We will need to provide the name of the table that we would like to fetch and an initial state, which is going to be an empty object for now. We received the response and it contains the data extracted from the Typeform API. However, it contains an items array property instead of just containing the data array itself. We also get some additional information which we will use to handle pagination. We will need to extract the items from the data. Now let's also implement the hasmore field and the state. In the request data, we will receive the state. This object will always contain the initial state or a continuation state, which we can define when returning our response. We can extract or initialize the current page. If this is the first call and the state is empty, we can default to the first page. Then we will need to provide this in the parameters. To see if we have more data to fetch, we can compare our current page number with the total page count returned by the Typeform API. Now we can replace the hard-coded value for the has more property. We are also going to add the state, which is going to be the number of the next page if we have more data. Otherwise, an empty state, so we can start fresh in the next sync. As there are only 2 forms in this demo account, we will force pagination by setting the page size to 1. The has more property is now true. We have 1 item in the response and we got the second page as our next state. When calling our function again with the new state, our has more is false. We receive the data from the second page and our state is empty. We have some unnecessary data in our data structure. Let's implement some cleanup. In this clean data function, we will loop through all the items and remove unnecessary information from them. We won't need the theme, self, and links fields, as these are only references for subsequent API calls. We can wrap our data with this function, so we'll return the correct format. Now the response contains the clean data. With this, we have successfully implemented the form endpoint. After implementing the forms, we also added the form response endpoint. We started by adding it to the getSchema function. Then, as the form responses are requested by form IDs, we needed to collect these by paginating through the API. The state handling had to be separated for the forms and form responses. The forms are still using pagination, but for the form responses, we need to track the form IDs in the state. In the first call, we are initializing them, and then we always take the first one from the list, using it for the URL. Handling the has more field also needed separation. In the case of form responses, we check if there are more form IDs remaining, and if so, we will set the new state to have the currently fetched form ID removed from the list, and then set has more to true. We've also added the possibility for the clean data function to append additional data to the items. This is because we need to add the ID to the form response. Let's test this endpoint as well. The Schema endpoint now returns both tables and their information. You can see the correct values for the form response object. This will make it possible for Weld to sync this table as well. To check the data fetching, we'll make a post request to the root endpoint. We can set up the request body, setting the name to form response. And then we can start with an empty state. As you can see, our has more property is true, and we get all the answers for the first form. And the state contains our remaining form IDs. We can make a request with the new state. Now the has more property is false. The insert property contains the answers for the second form. And our state is empty. The last step is to add authentication. We can do this by checking the authorization header. We expect that the value of this header will equal our Weld access token, which we will need to define. We are implementing a check, so if the authorization header and our predefined key don't match, we return a 401 HTTP error with the message unauthorized. We can test this by trying to make a request without any headers, and we get the 401 unauthorized response. Then when adding the header with the correct value, we should get a 200 OK response. This way we can ensure that there are no unauthorized calls to our Cloud function. Now let's deploy this solution to Google Cloud. We are going to use the inline editor to create a function. We will give our service a name, then we'll choose Python 3.13. We are going to disable Cloud IAM authentication. Then we will set up our environment variables to be able to authenticate the Cloud function and the Typeform API. After that, by pressing Create, Google Cloud will initialize the Cloud function. We will set up the entry point and insert our code into this editor. In the requirements.txt file, we will need to add our dependencies, then save and deploy the function. After the deployment is done, let's go ahead and test it with a call to get form data. We also need to add our authorization header. Now click Test in Cloud Shell. This will spawn a Cloud shell where we will have a prepared curl command to make the test call. When executing the command, we should see a successful response with the desired result. Now I will show you how to set this up in Weld. We will choose the custom connector and we will need to find and insert the self-hosted endpoint. We are also going to input our bearer token. Then we can click Connect. Here we have the option to enable deduplication if the source tends to create duplicates. You can see that Weld automatically found the available tables and the fields inside them. Here we can choose how often we want to sync the data. When done, Weld will create and start the sync. Now our initial sync is in progress and we can follow the status in Weld. Once our sync is done, we can take a look at a preview of our data. As you can see, our Typeform data is now stored in our data warehouse.